Hello there. This video is for anyone who may be stuck at the recursion challenge in the freeCodeCamp Basic JavaScript course, Replace Loops Using Recursion. To help you understand recursion and pass this challenge, we're going to take the multiplication example provided by freeCodeCamp here at the side and walk through it step by step. Now, first of all, we have to understand what task this recursive function aims to accomplish. So as you can see, the function multiply takes two parameters, an array and a number. And the task is to multiply the first n elements of the array to create the product of those elements. So if we copy and paste this function into our HTML file here, and we call this function with array with the values 2, 3, 4, 5, and number at 3, what this function aims to do is to multiply 2 by 3, producing 6, and then multiply 6 by 4, producing 24. So if we console log this function, and the code works, we would expect to see the value 24 printed in the console. That is in fact what we have. But why does this function work? Because when you look at this for the first time, it's very hard to see what it's really doing. So let's walk through the function line by line and see exactly what it does. So the first line of our function is an if statement. Now what is that doing? It's checking whether n is equal to or less than 0. If it is equal to or less than 0, it's going to return the value 1. Now we'll get back to this if statement later, but all we need to know for now is that because we call this function with n equals to 3, n is not equal to or less than 0, and so we skip this, and instead we jump to the else code. So what is the else code? So you can see that the else code is returning the result of what seems to be a mathematical operation. But it isn't immediately clear what this mathematical operation is. We're taking the return value of a new version of our function, where n is decremented by 1, and multiplying that by an index of the array. What exactly does this mean? In concrete terms, what is the return value of this new function where n is decremented by 1? Well, if you don't know, you're in good company, because the computer doesn't know either. To know what the return value of this new version of the function is, you would have to run this new version of the function and see what value it returns. And so that's exactly what the computer does. It skips this mathematical operation for now and goes into the second call of our function with n decremented by 1, i.e. where n equals 2. So now we're in a new version of the function where n equals 2. And first, the function checks whether n is equal to or less than 0, which it's not. So again, we skip this and go to the else code. And what is the else code? The else code is returning the return value of yet another version of our function with n decremented again times an index of the array. So in other words, we have the exact same problem as before. We don't have a concrete return value. And to find out what value we're multiplying here, the computer has to run this new version of our function where n is decremented yet again from 2 to 1. But in this new function call where n equals 1, we run into the exact same problem as we did the first two times. To find out the return value of the function with n minus 1, we have to go into that function call. So now we run the version of the function where n equals 0. And here you'll notice a major difference. When we come to execute this version of the function where n equals 0, this if statement will return true, and will return the number 1. So here you need to notice two things. One is that this time we're not going to call a new version of our function, because we never reached the else code. And this prevents the function from calling itself infinitely with n decremented each time. The other thing you should notice is that we actually finally have a return value, which is the number 1. So the version of the function where n equals 0 returns the value 1. And now that we have a concrete return value, we can start winding back and performing the operations that we skipped earlier. So first we wind back to the function call where n equals 1. And now you see that this is a coherent mathematical operation. The return value of the function call with n minus 1, i.e. 0, is 1, as we saw earlier. So this represents 1 times index n minus 1 of the array. Now n is currently 1, so n minus 1 is 0. So it's 1 times index 0 of the array. Index 0 of the array is the number 2. It's 1 times 2. And that's what this version of the function is returning, the number 2. So now we can wind back to the version of the function where n equals 2. And here again we have a coherent mathematical operation. The return value of the version of the function where n equals 1, i.e. 2, times index n minus 1 of the array. And as n is now 2, n minus 1 is 1. So index 1 of the array, so 3. So in other words, 2 times 3. So the version of the function where n equals 2 is returning 2 times 3, or in other words, 6. And now we can finally wind back to the original version of the function where n equals 3. And here we once again have a coherent mathematical expression. We return the return value of the version of the function where n equals 2, i.e. 6, times index n minus 1 of the array. And as n is now 3, n minus 1 is 2. So index 2 of the array is the number 4, so 6 times 4. And that is what this version of the function is returning. And that is why, when we console log this function with these arguments, we get 24 printed to the console. So I hope things are a little bit clearer now. I know I struggle with this, and I hope this helps.